Hello, students. These are the topic tests that we have prepared for you at Bodhee Prep. The idea behind these topic tests are that once you've done the basic concepts of a topic, you can come to these tests and see whether you're able to apply those concepts in the exam or not. Ideally, once you give a test, you can look at the video. Every test has a video attached. So, in the video, we give you the solutions and a broad analysis of the paper, question wise and overall. If you do like the test, there are more than 200 such tests available on the Bodhee Prep Android app. The link for the app is in the description below. So please download the app and make use of these tests. This test video is on the topic remainders, and this the test number 1 on remainders. Overall, this was an easy to moderate level of difficulty test. About 7 questions could be attempted easily, and the attempt time would be somewhere around 20 minutes. Some of the questions were really direct. One or two questions which required some amount of application. If we look at the questions, this is question number 1. N is equal to 1421 into 1423 into 1425. What is the remainder when n is divided by 12? Now, if we look at the multiple of 12, so 1421 divided by 12. Ones are 12, 2 ones are 12, 8 1, sorry, 101, 8 are 96, and therefore the remainder 5. So when we divide this by 12, the remainder here will be 5, the remainder here will be 5 plus 2, 7, and the remainder here will be 7 plus 2, 9. And therefore the net remainder will be 5 into 3 into 9. Again, we have to multiply, so 5 3s are 15. 15 by 12 is this will be 7, not 3. 5, 7, 9. We have wrote it wrong. So this becomes 5 into 7 into 9. 1421, 5, 1423, 7, 1425, 9. Now 5 sevens are 35. 7 9 is 63. Or rather, multiply these two here. 7 9s are 63. 63 divided by 12 is a remainder of 3. So from here we get 5 into 3. 5 3s are 15. 15 by 12 is the remainder of again 3. So the answer here will be option C, which is 3. Again, easy question, basic application of the concept. Should be able to do this in about 90 odd seconds. What is the remainder when 2 raised to power 2004 is divided by 7? A power of 2 close to a multiple of 7 is 8, 2 cube. So from 2004 we take out the power 3. 2004 by 3 will be 3 6 are 18, 2 0 6 are 18, 668. So basically 2 raised to power 2004 can be written as 2 cube raised to power 668 divided by 7. 2 cube is 8. So we need the remainder here. 8 can be written as 7 plus 1. So 7 is divisible by 7. The remainder will be 1. So the overall remainder will be 1 raised to power 668, which is nothing but 1. Option B becomes the answer. Direct question. Should not take more than 1.5 minutes to solve. Easy as far as difficulty is concerned. What is the remainder? 5 raised to power 60, 52 raised to power 60 is divided by 31. Now we can use multiple ways of solving the question. If we go step by step, for example, 52 raised to power 60 divided by 31. 52. 52 is nothing but 62 minus 10 raised to power 60 divided by 31. So from here we'll get the remainder as minus 10 raised to power 60, which is nothing but 10 raised to power 60. 10 raised to power 60 divided by 31 can be written as 10 squared. 100 raised to power 30 divided by 31, and 100 is nothing but 93 plus 7. So from here we get the remainder as 7 raised to power 30, and we are dividing it by 31. 7 cube then 343, 341. 2. 7 cube, this becomes 343 raised to power 10 upon 31. 343 divided by 31 will be a remainder of 2, because 343 is 341 plus 2. This further becomes 2 raised to power 10 divided by 31. 2 raised to power 10 is 2, 4, 8, 16, 32. 2 raised to power 5 square upon 31. This is nothing but 32 into 32 divided by 31. Both the cases remainder is 1, so overall remainder is 1. Or we can use a Euler quotient method to find the remainder. It says x raised to power Euler number of z divided by z has a remainder of 1, where x and z are co-prime. Now z here is 31, so Euler number for z will be 31 into 1 minus 1 upon 31. Since it is prime, it will simply be 30. And therefore we can say 52 raised to power 30 divided by 31 will have a remainder of 1. And therefore 52 raised to power 30 into 52 raised to power 30, which is 52 raised to power 60, will also have a remainder of 1. That is the answer. Either of the methods that you think is more intuitive, we can be followed. So again, maybe a moderate level of question, especially if you're doing the first method, but still should solve this in about 2 minutes, 2.5 minutes. This question should be solved. Remainder when 5 raised to power 37 is divided by 63. Power of 5 close to a multiple of 63 will be 125, 126. So if we write this as 5 raised to power 37, we cannot take the square out. So we write it as 5 into 5 raised to power 36. This can be written as 5 into 5 squared raised to power 18, which further becomes 5 into 5 squared, or rather cube we need, 125. We'll take out cube from here. 36 by 3 is 12. This becomes 125 raised to power 12 by 63. 125 can be written as 126 minus 1. 126 is divisible by 63. So from here we will get the remainder as 5. From here, because 126 is divisible by 63, we'll get the remainder as minus 1 raised to power 12, which is nothing but minus 1. So the overall remainder will be 5 into 1, which is 5 becomes the answer. Again, 2 steps involved, so I'll say moderate, but the attempt time should be under 2 minutes for this question as well. Find the remainder when 7 raised to power 52 is divided by 2402. Because the divisor is large, we start raising the power of 7. 7 power is 7. 7 squared is 49. 7 cube is 343. 7 raised to, we'll try to reach as close to 2402 as possible. 7 raised to power 4 is 721, 2801, 2401. 2401. 2401, which is one less than 2402. So 7 raised to power 52 can be written as 7 raised to power 4 raised to power 13, which becomes 2401. This becomes 2401 raised to power 13 divided by 2402 is the remainder that we're looking for. 2401 is nothing but 2402 minus 1 upon 2402. The first part is divisible by 2402. Minus 1 therefore will be the remainder. And every time the division happens, minus 1 will be the remainder. So the overall remainder here will be minus 1 raised to power 13, which will come out to minus 1. Negative remainder means the positive remainder will be divisor plus the negative remainder, which is 2401 becomes the answer. Standard remainder concepts, nothing new per se, but since there are 2-3 steps involved, so I'm saying moderate question, about 2 minutes to solve. If when 950 and 1170 are divided by natural number d, 950 is divided by d, 1170 is divided by d, the remainders obtained are 18 and 5 respectively, then d is at most. Since on dividing 950 by d we get remainder 18, we can say 950 minus 18, which is 932. 932 is divisible by d. Similarly, in the second case, 1170 minus 5, that is 1165. 1165 is also divisible by d. We want to find the largest value of d. So basically, we are looking for the largest divisor of 932 and 1165. We can factorize or look at the difference. If we factorize 5 to the 10, 16, 233. 233 into 4. 21, 4, 21, 431, 900. So 232 is 233 into 4. we could simply have taken the difference as well. This is 233 into 5. Clearly, the largest number which is common in both of them is 233. The value of D is 233. Again, no, the concept uses is pretty simple. Just take out the remainder and take the HCF in a way. And therefore, I am saying 1.5 minutes to solve the question, easy question. What is the remainder when 25 raised to power 25 is divided by 9? Now, there are two approaches that come to mind. One could be that we start raising the power of 25 and see if it comes close to a multiple of 9. But again, beyond 25, it will be difficult to do. So instead of doing that, we can say 25 raised to power 25 is nothing but 18 plus 7 raised to power 25 divided by 9. 18 is divisible by 9, so the remainder will be 7 raised to power 25, and we will check the remainder when divided by 9. Now we work with powers of 7. 7 square 49, 4 plus 9 is 13, 7 cube is 343, and 343 has a sum of digits is 10. So with 9, it will leave a remainder of 1. So I cannot take the cube here, so I am writing 7 raised to power 25, 7 into 7 raised to power 24. This becomes 7 into 7 cube raised to power 8. This becomes 7 into 343 raised to power 8 divided by 9. 343 by 9 will be a remainder of 1 because the sum of digits is 4 plus 3, 7 plus 3, 10. So remainder of 1. And this 7 will be there as it is. So the overall remainder will be 7 and that becomes the answer. What we could have also done was 7 sevens are 49. The initial value was 7, 2 plus 5, 7. We could have also looked at the cyclicity. That could also have been one way to solve this question. But again, overall, I'd say not a very difficult question to solve. 2.5 odd minutes should be good enough to get this question done. Find the remainder and 40 factorial is divided by 41. So Wilson's theorem says that n minus 1 factorial upon n will leave a remainder of n minus 1 where n is prime. N is prime. This is the exact expression of the question. 41 is prime. So 40 factorial upon 41 will leave a remainder of 41 minus 1, which is 40 becomes the answer. Again, it's a basic formula on which there have been questions in old CAT examinations. So if you've done remainders, you would have come across this, and therefore I'm saying moderate question. I mean, you have to know formula for this, but the solving time is not very high. What is the remainder? 1 raised to power 1, 2 raised to power 2, plus 3 raised to power 3, 4 raised to power 4, up till 9 raised to power 9, plus 10 raised to power 9, minus 11 raised to power 8, plus 12 raised to power 7, minus 13 raised to power 6, and so on till 18 raised to power 1 is divided by 19. So what we can do is we can club numbers with the same powers. So this becomes 1 raised to power 1 plus 18 raised to power 1, 2 raised to power 2 minus 17 raised to power 2, 3 raised to power 3 plus 3 and 16 raised to power 3, 4 raised to power 4 minus 15 raised to power 4, 5 raised to power 5 plus 14 raised to power 5, 6 raised to power 6 plus 13 raised to power 6, and so on. 7, 13 is minus, not plus. Basically, the sign is alternating and one value decreases, the other increases. Now here, if we know from the identities that a raised to power n plus b raised to power n is divisible by a plus b when n is odd, and therefore a raised to power n plus b raised, this is divisible by 19, 8 plus 1, 18 plus 1. This is divisible by 19, this is divisible by 19, this is divisible by 19, and this is divisible by 19. 10 plus 9, 19, 7 plus 12, 5 plus 14, and so on. Also, an minus b raised to power n is divisible by both a plus b and a minus b. when n is even. Therefore, 2 square minus 17 square will be divisible by 2 minus 17. Here a is 2, 2 plus 17 and 2 minus 17, sorry. So yeah, a raised to power n minus b raised to power n will be divisible by a plus b and a minus b. So we can for now remove the a minus b term because that is not required. But what we can say is because the powers are even, this will be divisible by 2 plus 17, this will be divisible by 4 plus 15, again 19. This will be divisible by 6 plus 13, 19. This will be divisible by 11 plus 8, 19. So all the terms individually are divisible by 19, and therefore the sum of all of these terms will also be divisible by 19. So when you divide a term which is divisible by 19 itself, we get the remainder as 0, and that becomes the answer. I think it's a moderate sort of a question because on first glance the expression looks a little absurd, but you would have come across such questions in during practice, and therefore probably something that should be done in the exam as well. And once we get the pattern, you don't have to write all the details. So even the first 2-3 terms, if you're able to identify, the question is done. So about 2 minutes should be good enough to answer the question. N factorial is defined as a product of natural numbers from 1 to n where n is greater than or equal to 1. P is a number which is 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial and so on. P plus 2 is divided by 11 factorial. This will leave a remainder of. Now, if you look at P plus 2, I'm taking two terms at a time. So I'm just taking these two terms and then the rest of it. We can write 2 plus this 2 plus 1 factorial plus 2 into 2 factorial. And then the terms after that. 1 factorial is 1, so this becomes 3 plus 2 into 2 factorial. Or rather, if you don't take the 2, we just take 1 here so that there is a common term to add. So what I'm doing, I'm starting with p plus 1. The logic being, if I look at 1 plus 1, 2, I can take the 2 common. 2 is equal to 2 factorial. So I can take the 2 factorial common. Here we are left with 1, here we are left with 2. So this becomes 2 factorial into 3, which is 3 factorial. Beyond this, we had 3 into 3 factorial, 4 into 4 factorial, and so on. So here again, now if we look at these two terms, we get 3 factorial from here, 2 factorial into 3, plus 3 into 3 factorial. We can take the 3 factorial common in these two terms. Here we will be left with 1, here we will be left with 4. 3 factorial, here we will be left with 3. 3 plus 1 is 4. So this becomes 4 factorial. This gets added to the next term, which is 4 into 4 factorial from the definition of P. We can take 4 factorial common, we are left with 1, here we are left with 4. So this becomes 4 factorial into 5, which is 5 factorial. This 5 factorial then gets added to the next one. So the last term that we'll get is 10 factorial plus 10 into 10 factorial, which will be taking 10 factorial common. 1 plus 10, which is 11 factorial, becomes the answer. So we can say P plus 1 is equal to 11 factorial. And therefore, P plus 2 will be 11 factorial plus 1. We are dividing P plus 2 by 11 factorial. If we divide this, the first part will divide. The remainder will be 1, option D. Again, it's a difficult question. Solve this only if you have done a similar question earlier. Otherwise, even then, you take 2.5 minutes to solve it. In the first try in the exam, this might actually not happen. So if you look at the overall test, as as discussed initially, easy to moderate sort of a test. About 20 minutes should be good enough to get 7 questions net correct, which will give you a 95 plus percentile. If I had to choose the 7 questions, which will be my 7 questions, for me the easiest of the questions were 1, 2, 4, 5, 6, 8, and 9. Which are these? Definitely doing this one. One of the most basic applications of remainders. Would have done this since was able to solve this in one step. This I think was a better question. Could have left it if I'm choosing the 7 easiest. This will not be part of that. Again, this I think was an easy question. Just one raising the power once, we get 126. Raising the power 4, we got the number, so would have done this as well. would have attempted this question as well because we're just looking at the HCF of two numbers in a way. This question again could be taken a call on. If I'm looking at the easiest ones, this will be not part of my list. This was again a direct application of Wilson theorem, but again, if you can take a call among 7 and 8, if I don't know Wilson's, I will be doing 7. If I know Wilson's, I'll be doing 8. This, I think, again is a repeated pattern. The moment you see that 1 plus 18 is 19, 2 and 17 is 19. So basically, same powers becomes an easy question to solve. So I would have done it. This question, again, not for something that I'll do in the test, for certainly not something that I'll do for the easiest 7 questions, unless I have done this question earlier. So would have left it as well. Hence, my list will be 1, 2, 4, 5, 6, 8, 9. You could replace 8 by 7 if you're not comfortable with the Wilson theorem.